Welcome. Today we discuss some problems on the chapter three-dimensional geometry. Let us take the first problem. It is if a point A 1 2k B k 1 2 and C 10 -1 -2 are collinear. These 3 points are collinear, then k is, value of k is options -1, 3, 4 and -2. Straightforward problem. The three points are given in 3-dimension geometry and their coordinates are given. We have to given that they are collinear, lying on same straight line. Therefore, value of k will be equal to, if three points are collinear, A, B and C, then direction ratio of AB and direction ratio of BC must be same. Now from there, direction ratio of AB is equal to x2 minus x1, that is k minus 1, 1 minus 2, 2 minus k, and direction ratio of BC. It is 10 minus k minus 1 minus 1 and minus 2 minus 2. The direction ratios of AB and BC are given by that. Therefore, their ratios must be same. Hence, k minus 1 by 10 minus k is equal to minus 1 by minus 2 is equal to 2 minus k by minus 4. Now, equating first two ratios, k minus 1 by 10 minus k is equal to half. That is 2k minus 2 is equal to 10 minus k. 2k minus 2, so that we get 3k. 3k is equal to 12. That is k is equal to 4. Now let us see whether k is equal to 4 satisfies this relation also. So comparing second and third ratio, we must get 2 minus k by minus 4 is equal to half. By same approach, 4 minus 2k is equal to minus 4. That is 2k. This 2k in that side is equal to 8. That is k is equal to 4. So this value also gives k is equal to 4. So that if k is equal to 4, these 3 points are collinear. So this is our answer. Now, the next problem. direction ratio of two straight lines are 413 and -1 2, 0, then direction cosine. Now direction cosine, this is direction ratio. Direction ratio of direction cosine of a line which is perpendicular to both this and that. And options 2, 1, -3, then 2 by 14, write it there, 2 by √14, 1 by √14, and -3 by √14. Then next 2 by √14, comma, -1 by √14 and 3 by √14, and last one is 2 by √14, 1 by √14 and 3 by √14. So the four options are there. So this problem is also straightforward with the help of the previous formula what we discussed in last day. With the help of that, very easily we can do that. Problem is, once again I am discussing, two straight lines are given whose direction ratio this and that. We have to find the direction cosine of a line which is perpendicular to both this and that. Suppose direction cosine, let us find direction ratio of third line be ABC. If I can calculate direction ratio this, from direction ratio, direction cosine very easily can be obtained. Now, as because this straight line whose direction ratio is this is perpendicular to this as well as perpendicular to that. Therefore, the dot product, that is 4A plus B plus 3C must be equal to 0 as because they are perpendicular. Similarly, they are perpendicular, that is minus A plus 2B plus 0 into C, that is 0, is equal to 0. Now from these two, we can, by using cross multiplication, very easily can calculate the ratio of A, B and C. So A is equal to A column 0 minus 6, 0 minus 6 is equal to B by 3 into minus 1, minus 3 minus 4 into 0 is 0, is equal to C by 8 plus 1. That is, we get A by minus 6 is equal to B by minus 3 is equal to C by 9. That is, A by, cancelling by minus 3, 2 is equal to B by 1 is equal to C by 3. So direction ratio of the line which is perpendicular to both this and that is equal to 2, 1, 3. This must be minus 3. You see? So this is direction ratio. From direction ratio, we can calculate direction cosine. Its magnitude is root over of 4 plus 1 plus 9. Direction ratio is, oh, 1 second, I have mistaken. Achha, minus 3 whole square is 9. So root 14. So the required direction cosine is 2 by root 14, 1 by root 14, minus 3 by root 14. So this is required direction cosine of the required straight line. So this is our correct answer. Next, third problem is the direction ratio of a line L is direction ratio of a line L is 534 and A, capital A is a point 3 1 minus 2, B is another point 4 minus 1 3 are two given points. One line is given whose direction ratio is this, and two given points A and B, the three-dimensional coordinate are given. To find the projection of AB on L, projection of AB on L. This is the problem. That's because root over of 5 square plus 3 square plus 4 square is equal to 25 plus 9 plus 16. It is root 50, so 5 root 2. So direction cosine of line L is 5 by 5 root 2, 3 by 5 root 2, and 4 by 5 root 2. This is direction cosine of the given line. To find the projection of a line segment on that line is, formula is L into x2 minus x1, x2 minus x1 plus m is this, y2 minus y1 plus n into plus 2, of course with the modular sign. Oh, actually I have not given the options. Let us first of all, I write down it. Option is 9 by, I am writing it here, 9 by 5 root 2, 19 by 5 root 2, root 3, sorry, 19 by 5 root 2, and 17 by 3 root 2. These are the options. Achha, anyway, just now I told you this is the formula, working formula for calculating projection of a line segment on a line whose direction cosine is known to us. This is direction cosine. So as per condition, L is our required projection is equal to, L means L is this, 5 by 5 root 2 into x2 minus x1, x2 minus x1, 3 minus 5 plus M is your 3 by 5 root 2 into y2 minus y1. y2 minus y1 is y2 minus y1, that is 1 minus 3 plus n means 4 into 4 by 5 root 2 into z2 minus z1, 3 minus plus 2, its modulus value is equal to 5. I mean 5 root 2 is common in denominator, so 5 into minus 2 plus 3 into minus 2 plus 4 into 5, that divided by 5 root 5 root 2, its mod, that is, it is 20. This is minus 10 minus 6 minus 16 plus 20, therefore it is minus 10 minus 16, they together, this is 20, so 4 by 5 root 2. In option, no value like that, so let us check the calculation. So L, this is 5, just 1 minute, I check the 5, 3, 4, and A point is 3, 1 minus 2, and B point is 4 minus 1, 3. Okay, then this is direction cosine of the line, that is also all right, and formula is L into x2 minus x1, 4 minus 3, what I write, sorry, this is L into x2 minus x1, x2 minus x1, that is 4 minus 3, sorry, 4 minus 3 plus m is your m 3 by root 5 into y2 minus y1, y2 is minus 1 and minus 1, this is equal to minus 1 plus 4 by root 5 into 3 minus plus 2, so that we get 5 into 1, and this is common. This one is 3 into minus 2 plus 4 into 5 by 5 root 2 mod sine, so that this is equal to 20 plus 5, 25 minus 6, so that 19 by 5 root 2, so that this is our correct answer. Next, problem is vector equation of a straight line whose Cartesian form is x is equal to y is equal to z. This is Cartesian equation of a straight line. We have to find its vector equation. No, we have to find Cartesian equation of a straight line No, just 1 minute. Very sorry. To find vector equation of a straight line whose Cartesian form is that. Acha, this Cartesian equation can be taken to the symmetric form, which is x minus 0 by 1, x minus 0 by 1 is equal to y minus 0 by 1 is equal to z minus 0 by 1. It means the straight line passes through 0, 0, 0 and whose direction ratio is 1 is to 1, 1, 1. Achha, I have forgotten to give the options. Options is r is equal to t minus 2 into I plus t minus 3 into j plus tk. Second option is r is equal to t into I plus j plus k. Third option is all vectors. Third option is t minus 1 into I, t plus 2 into j plus tk. And fourth one is ti plus t plus 3 into j plus t minus 1 into k. Achha, so I'm repeating the problem. We have to find the vector equation of a straight line whose Cartesian equation is this. This Cartesian equation can be written to the symmetric form as that. And it means, from symmetric form, it means it passes through the point 0, 0, 0 and whose direction ratio is 1, 1, 1. So its vector form is, normally we know that r is equal to a plus t into b. A is the vector through which the straight line passes and b is the vector which is parallel to a given vector. Now here a is 0, 0, 0. So it is 0i plus 0j plus 0k. This is A. And B is the vector with parallel vector. It is actually t into 1 into I plus 1 into j plus 1 into k. So answer is r is equal to this. Means second option is correct. Now our next problem. The Cartesian equation of a straight line which passes through a vector, position vector is A, and B, point B, whose position vector is B, where A is equal to 2I minus 3j plus 3k, and B vector, that B vector is equal to I plus 3j minus 2k. The question is to find the Cartesian equation of a straight line which passes through this point and that point, and where this position vector A and B is given by that. Achha, we know that vector equation of a straight line which passes through A and B is R is equal to A vector plus some constant into B minus A vector. We know it. So, options not yet given. Oh, every time I am forgetting it. Acha. Options are x minus 2 by 1 is equal to y plus 3 by 6 is equal to z minus 3 by minus 5. Secondly, x minus 2 by 2 is equal to y plus 3 by 5 is equal to z minus 3 by 5. Thirdly, x minus 1 by 1 is equal to y minus 2 by 4 is equal to z minus 3 by 5. And fourth option is x plus 1 by 1 is equal to y plus 3 divided. So, once again, I am repeating the problem. A straight line passes through this vector and that vector, where A is this, B is that. Then, to find its vector equation, I have written here the vector equation of a straight line passing through two given points is that T is a parameter. So, here it is equal to R is equal to R vector is equal to A vector means 2i minus 3j plus 3k plus t into B minus A vector, this minus that minus I, 3 minus minus 3 plus minus 2 minus 3, that is minus 2 minus 3, that is minus 5k. That is, it is equal to 2 minus t into I plus minus 3 plus 6 t j plus 3 minus 5t into k. R vector is equal to xi plus yj plus zk. So that we get x is equal to 2 minus t, comparing coefficients of I, j and k, etc. Y is equal to minus 3 plus 6t and z is equal to 3 minus 5t. Now from here, t is equal to, from this, x minus 2 is equal to minus t by minus 1 is equal to t, y plus 3 divided by 6, that is also equal to t, and z minus 3 by minus 5 is equal to t. So that our answer, this is t, this is t, this is t. So our answer is x minus 2 by minus 1 is equal to y plus 3 divided by 6 is equal to z minus 3 by minus 5. And or its simplified version. So answer is x minus 2 by minus 1. Oh, answer is x minus 2 by minus 1, y plus 3 by 6 and z minus 3 by minus 5. Yes, answer is given as that. This is -1. Rectify it. So this is our answer. Actually, what we do here, it is, I have used the formula. If a straight line passes through a given vector point and parallel to and passes to other this and that two vectors, formula is this. I simplify it, and after that, r vector is equal to xi position vector, xi plus yj plus zk. Comparing coefficients of I, j, and k, we get three equations. From there, I eliminate t. From this t is that, from this t is this, and now equating them, we get answer. Next problem is the vector equation of a line, straight line, passing through -2, 1, 0, and perpendicular to both. R is equal to 2i plus 5j minus k plus t times 2i plus 3j plus k, and r is equal to I minus j plus 2k plus s. T and s are parameters. I plus 2j plus 3k. Options. R is equal to minus 2i plus j plus t times 7i minus 5j plus 5 plus k only. Second one, R is equal to minus 2i plus j plus 5k plus t times 2i minus j. That's all. R is equal to minus 2i plus j plus t times 3i plus j minus k, and fourth one is minus 2i plus j plus t times 2i plus j minus 4k. I repeat the problem. What is the problem? A straight line passes through this point, and the straight line is perpendicular to this line and that line also. About this straight line passes through the point 2, 5, minus 1, and it is perpendicular and it is parallel to 2i plus 3j plus k vector. Similarly, for this, we have to find a vector equation of a straight line which passes through that point and which is perpendicular to both this and that. The actually required straight line will be perpendicular to the vector, both the vectors this and that, and that is cross product of this and that, which is equal to I, j, k. I find the vector product of this and that, 2, 3, 1. 1, 2, 3 is equal to I into 9 minus 2. 9 minus 2, that is 7i, plus j times 1 minus 6, that is minus 5. Then 4 minus 3, that is 1k. This is equal to that. That means the straight line which is perpendicular to both this and that is parallel to this. So our required straight line passes through this and parallel to that, which is equal to r is equal to minus 2i plus 1 into j plus 0 into k plus t times 7i minus 5j plus k. So first option is correct. Okay. So, okay, today is up to this. If you feel that this is helpful for you, so please like it, share it, and subscribe it. Thank you.